everyone, my name is Leah. I'm not a stunt person or a boxer. Actually, I'm an explainer here at the New York Hall of Science. Have you ever wondered about the science behind the cool fight scenes that you've seen in action films? Well, I love action films, and when I finish watching them, I do a little bit of research to find out what really goes on behind the scenes. And I found out what makes such an exciting fight scene. It's physics. What is physics? Well, physics is a type of science that involves matter and energy. Energy can take on many forms like light or sound. It also involves motion and something called force. Today we're going to focus on how matter, energy, and force work together to create the great fight scenes you see on films. So here are some things we just want to keep in mind. The first being matter is anything that has mass and takes up space. You and I are made up of matter, so is your cell phone, your car, and even a tennis ball. The second thing we want to remember is that force is a push or a pull on an object that occurs when two or more objects interact with each other, like the fist of a fighter and the body of their opponent. And the third thing we want to remember in regards to matter is that energy is the capacity to do work. It can exist as potential energy, which is stored energy, or kinetic energy, which is energy in motion. However, keep in mind that energy cannot be created or destroyed. So now let's see some physics in action. So what you'll need for this activity is a tennis ball, string, length may vary depending on the height of where the ball will be attached, and a knife. So I recommend seeking adult supervision. What you're going to do with the knife is make two small incisions in the tennis ball that are parallel to one another like this. Okay, and here's the second one. So after you make the incisions, you're gonna take your string and you're gonna loop it through the holes, tightly securing the knot. And when you're finished, it'll look something like this. So as you can see, I've attached my tennis ball here to this beam overhead, so it's freely suspended. You could do the same, or you could find an alternative such as attaching your tennis ball to a hook or a fastener in an open doorway. We're gonna explore some interesting concepts about energy using this tennis ball. As I raise this tennis ball to its highest point here at my face, it gains something called stored energy as I lift it straight up. This is also called potential energy. When I release the ball, the stored energy transforms into kinetic energy, which is energy in motion. Some of that kinetic energy will be lost due to the friction between the ball and the air. This loss of energy will prevent the ball from rising to its starting point and hitting my face. But what do you think would happen if I add an external force, such as my fist? So let's see what's going to happen when I transfer energy to the tennis ball with a punch. So when I punch the tennis ball, I'm exerting a force from my fist onto the tennis ball. This is called an energy transfer, when energy moves from one object to another. So as you know, there are different types of energy, which means that there will be different types of energy transfers. So as I move my arm, the kinetic energy that the movement generates is called mechanical energy. So for example, when I'm punching the tennis ball, this is an example of a mechanical energy transfer that happens by the action of a force. Remember, as I punch this tennis ball, I'm adding energy. So 3, potentially 4 things will happen. 1, the ball begins moving because kinetic energy from my fist will be transferred to the ball. 2, the ball will absorb some of the energy, staying as potential energy within the ball. 3, there will be an opposing reaction, meaning the ball will exert a force back onto my fist. This occurs because of Newton's third law of motion, which says for every action there is an equal and opposite reaction. And 4, I get hit in the face and the energy from the ball gives me a black eye if I don't react fast enough. Now, in movie fight scenes, throwing a punch is one of the main energy transfers that occurs. As fighter A exerts a force by punching fighter B, some of the energy generated by the mechanical force will be transferred onto fighter B and some of it will be absorbed. According to Newton's third law of motion, for every action there is an equal and opposite reaction. This means it's very likely that any force exerted on fighter B could result in an equal and opposite reaction that causes injury to fighter A's wrist. Alright, so to wrap this all up, let's remember some of the science behind the fighting scenes we saw today. So energy is the capacity to do work, and when a force is exerted onto another object, this is called an energy transfer. And energy transfers allow matter to move further and faster. So now that we've covered the physics of fight scenes, I wonder what other STEM concepts we could find in action films.
I'll leave you with that thought. Now if you'll excuse me, I'm about to go practice some energy transfers. Thanks for watching.